What's the best way to clean out a low pH iron oxidation system? One related to acid mine drainage. Good question. And I'm here to give you some of those answers then. Okay, so what we have here is the influent pipe. This is KL1 Klondike, Clearfield Creek Watershed Association. Dr. Arthur Rose, Penn State Emeritus, is taking the samples, and I maintain the system. I'm Colin, Director of Biomining Products in EcoIslands, and we build self-organizing wetland bioreactors. And this water, this mine drainage water, has about 100 milligrams of ferrous iron. It's running right now about 35 or 40 in total. And what you're seeing here is the influent pipe. One of the things about low pH iron is under this pH, right now we're at a range of about 3.2, is that different kinds of archaea or microbes are using the iron, the dissolved iron in the water, as an energy source. And then their byproduct is called schwertmanite or goethite. That is all this red stuff you see right here. And it actually produces terraces because it requires oxygen as well. It's a biological process, in this case using oxygen from the atmosphere. And they make those terraces, and this is very much like in Yellowstone and in other thermal vent zones. This came originally from the pyrite in the lode that was associated with the coal mining that originally got this started here like 50, 60 years ago. So it builds up in terraces. And because it builds up like that, in one direction, the direction where the oxygen is, which is also where the water interface is, you end up getting concretions and kind of like plaque in your arteries, slowly closing down the arteries. Low pH iron will do the exact same darn thing. So yeah, basically got to router them out. So pipe maintenance, top end of a system, things you got to do to maintain a system, pipe maintenance. If you're not doing this, after a year, you'll have nothing. There will be no flow rate going through there at all. Watched it happen lots of times, intentionally, just to see what the process and timing was. So it's really best if you do your pipe maintenance about every week to 2 then. A low pH iron system works very rapidly, almost to kind of a negative because it requires a little bit more labor. But simple things can cut down what would normally be pretty time consuming, like flushing and pipe maintenance. It's those basics, just like putting oil in your car, just the basics. So in this system, I've got I cheated. I used a small water bottle, put it on the other end of the string here, and that's floating down in the box. And then I just pull this up and through. Now, should be something like a chimney sweeps 4-inch barrel brush would be even better. I just haven't laid my hands on one. But this had got a system running from what it was originally when I was plugged up 12 gallons a minute with the filter on there to running about, I've seen it do 60 so far. And it will run a lot faster. Right now it was running about 30, no, it was 25 the tail end of the system when I measured it here just a little bit ago before I did anything. You always want to get your baseline. Come over here, sweep the pipe. I did it 3 times, and on the 3rd time, it was the bottle was definitely shooting back through the shot was going through even faster than it had been before. And then I'm gonna walk over here, just 1 minute. Okay, following along the pipeline, you can see there. This is an MRU. It's a Mark. This one's a 315, 1,500 gallons, 3 cells individually, self-organizing wetland bioreactor. And you can see in the first cell there that it is backed up. That's because the matrix that is at the bottom of the unit has accreted with enough of the schwertmanite and goethite materials, and we found it's a bit of both, and it might be concentration depending on what's going to form. But you can see there that it is backing up that the first baffle there, and that's fine. It's intentional. But because we don't have a lot of head pressure here, it also means that that level right there where it's very first coming into what's called the delivery vault and then going over the backside, the lower of the 2 bypass weirs, means that it's plugged up, and in this case that's also backing up the top portion of the system just a little bit so that some water is still allowed to flow through this bypass channel, which had already been in existence before we came and put the box in last year to do comparative studies. So, as in here in a minute, I'm going to be doing the draining on the other side. There's a manifold on the back side of it. The white pipes there are the pneumatic delivery bubbler system. I want to call it a fancy name. It's the bubbler pipes. And I'm going to run those. Also, getting down into the first cell, I want to see a profile. Like so if it's in overflow right now, how many inches thick of material at the bottom is required to get it into overflow? Because that'll also then inform if we can figure out the deposition rate per day. And I mean, you know what the accumulation is by iron removed going through the box. So you know a general number on the amount in kilograms per day that the box is pulling, or pounds kilograms per day. But this will give us a little bit more refined temperature data for plugging data for the first cell. Because you would just then flush it out more often or drain it more often with an automated system. We've got an OSM grant to put in 4 of these, of the newest design, right over there. They squeeze into a pretty small footprint. And they're the automated system then, so they'll have solar panels and automatic flushing, plus some other kind of basic data logging. And that will give us even more information. And then instead of a person having to come up and do the most important part of the maintenance, which is the draining, the box will do it automatically. You're still going to have somebody until we figure out automatic pipe sweepers. We're still going to have somebody come out and just take a look at it. But you'd kind of want to inspect it anyway. I mean, there's it's a mine drainage treatment system. What doesn't get caught here goes downstream. Okay, and I'm going to go ahead and start doing some of the clean out, and then I'll show you some of the results as we go through it. It's going to be kind of messy. Okay, hey all, just wanted to show you the pneumatic system here, regulator, and of course you can hear in the background. What I got over there is kind of overkill. It's what I got to work with at the moment. Okay, pressure lines. Whenever you're starting off, always just give it a light tap, especially in the winter if anything's freezing. I've had them pop off on me. Okay, and then cheater. But it works. Thank you, zip tie. And then if I want to increase the pressure, this guy right here. You can hear it bubbling away inside there. That's pretty good. This iteration's PVC, so don't really want it to blow apart. 1 second then. Okay, and then you can see it bubbling away there. And as it bubbles, it's flushing out over there. I'll actually just take you over here really quick. So this is the effluent pipe. Need to set up another bottle through it, but then it's bubbling away, beginning to knock a little bit of material loose. There will be more as it goes. Nice thing about Schwertmanite and other iron minerals that are formed this way through microbial processes is this stuff is dense, so it settles better. Doesn't require flocculant. You can see it dropping out even under some of these faster flows here. I'd like to point out that iron oxidizers that make these terraces are kind of like microbial beavers. And they continue to make those terraces. That's their thing, and they'll keep growing straight upwards. And that's one of the issues is they will change the morphology of a treatment wetland. Like on the other side, so you got two strips here then. Goes out, around, back, and down. This once again, this is KL1 Klondike up outside of Asheville, Pennsylvania. Coming over here, you can see it's starting to. Here, I'm not going to mess with it because it's not really flowing at all. I mean, there's a little bit of leakage there, but remember, it grows upwards, so it'll kind of actually stop itself. It's a biological feedback loop essentially. But this pond, this section here, isn't supposed to be this deep, and I don't know how well you can tell right here, but there's a little bit of a drop there. You got 1.5 feet, a good foot of drop. and that's all from reeds and creating a matrix and a basis for more iron to precipitate on, and then it can grow much faster vertically. And then it's backing up this pond. And I guess it's not really hurting anything, but the material, it grows on surface area with more oxygen available. That's why it grows straight up. It keeps moving, and it'll slowly move. I don't know how well you can see that. It's slowly growing this way and out is essentially what they're doing, what these terraces are doing, as a full lobe. And it doesn't really matter if this is 2 feet deep or 3 feet deep, or 6 inches deep would be the best, actually, and some organic material. Because just to demonstrate what I'm talking about here, if you look at the thickness and the material growing off of there creates a 3-dimensional matrix, versus out there, it's 2-dimensional. Just like over here, it's 2-dimensional. It grows upon a surface and growing up and out, kind of like tree rings, just going straight up in this case, and constant. You wouldn't really see the rings from the growth cycles. These things will operate at different rates depending on temperature as the winter goes on, but they'll still precipitate. The temperature doesn't stop them, it just slows them way down. So it's in the boxes, like I was saying, is the organic matrix, so you can compress this into this and get out useful amounts of material. Okay, I'm going to get to cleaning because there's a lot to do. Okay, flushing the last cell. Let's go last cell to the first. Really. So I just want to point out here that settling the iron, that's without flocculation. If using a flocculant like a polyacrylamide, which is got some chlorine in it, and it makes particles stick together, kind of like dust making rain. It's essentially what it does. We actually found, though, that the polymer doesn't work very effectively for the box, and it actually makes it plug even faster because the particles don't get a chance to effectively fill up the whole space of the matrix, and you effectively cut off a lot of what is useful, that volume to capture material. So I just wanted to show you that plume then. With you. This matrix that is flushed out underneath. Yeah. Water was nice and clear today until I got to it. This is still low pH iron water, by the way, so when I say that, I mean that's exactly, the dumping of this material into this pond is exactly what it's for. Or at least that's what's been purposed. Okay, so that's pretty good. Okay, so water's still running through the box. So cell 1 and cell 2. And I had cleared this. And it looks like the section that is plugging the fastest is really just only the first, I'd say, 2 or 3 inches. So the bubbler system here helps break that up, and the more effective bubbler system, when it's directly supporting the matrix itself, would probably be even better. Okay, going to keep on working here. I got the other 2 to do. That took me, I don't know, 10 minutes. Not even. Okay, this portion is for Dr. Rose. I told him I'd go out and get some of this stuff. So just wanted to take a look at what's going on here. And we got sheet-like patterns. I've said it before, I'll say it again. I think it looks like a Nine Inch Nails album. Big fan of Nine Inch Nails. Shout out to Trent. But the material, caking, the outside, and I have many times before seen preferential growth and preferential flow. So we see almost these nodes accumulating. And yeah, here, as I kind of peel that back, taking a look at it, we got just big old chunkers. We get the majority of our plugging in a system at the bottom, which means you either use less coir, which I'm not a fan for because then you miss all the rest that's up above. You just have to do bubbles and flushes to keep that very bottom section, which is actually beneficial because it's, well, there's the outflow right there in this particular manifold system. So just doing that bubbling process maybe every other day helps to distribute that. Yeah, look at this. You know, that's just bottom 2 or 3 inches. And within, so I've got a section right here. And how well you can see it, this is the bottom level of my hand. You know, so we're getting most of our plugging within bottom 6 inches, which is what I'd always suspected. It just, yeah, I mean, look at that. You know, sheet-like material that then grows outwards, which is, you know, it's what it's supposed to do. Yeah, I don't want to say like that's a real big negative, because that's what it's allowing it to be so damn effective in cleaning the iron. But, okay, I'm gonna hop out of the box. Just to give you some perspective then. So that's where we were. 4.8 cubic meters. So for the rest of the material here, then I'll just fill and empty it, stir it, and that knocks that material loose. And I could probably get away with even less material in it than this, actually. But all that was where I'm standing right now. So we'll probably leave it for now. Just kind of wanted to point out that it sort of reminds me of smoke from a volcano. Yeah, this is acid mine drainage, this is pollution, but there are some beauties to it. I like the job because I get to work outside. It's kind of the big one. Solve problems. See how it's swirling there. There's the third cell again. Just wanted to catch the other side real quick. Okay, back up at the top real quick while the second cell is flushing. Wanted to point out that when we brought the first cell's height down by alleviating some of the plugging issues at the bottom, the top pond then dropped. So the box is essentially taking full flow, which is going to be somewhere around 30 gallons a minute right now. Hey, okay. Got wrapped up. If I hadn't been doing the video portion, probably would have saved me, like half hour or so. I've been here about an hour and a half, 2 hours. Box is filling. Everything is equalized. You can see almost all the flow is going through the box and not the side here, but you still have there's still some seepage through the Schwartmanite dam there, you can see. And that should be good for about 2 weeks. Then at these rates and with this loading, 30, 40 gallons a minute, 100, 80 to 100 ferrous going in. And now I'm just gonna, and I did pull out some more coir, some more matrix there just to make it a little easier to clean it out later, because there's a point where there's just more than you need. And I think we're there. Okay, signing off.